Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B18A8, indicates a low voltage input detected at the right BSI radar unit in the Honda Odyssey models from 2011 to 2017. The BSI, or Blind Spot Information Radar Unit, is essential for detecting vehicles and obstacles in the blind spot of the vehicle, thus enhancing safety during lane changes. It is typically located on the side of the vehicle, near the right rear area, integrated within the body control system. When this DTC is triggered, it usually points to issues like poor connections, faulty wiring, or a malfunctioning radar unit. Immediate attention is crucial, as it can directly affect the vehicle's safety systems, thereby increasing the risk of accidents. To address this issue, a systematic approach to troubleshooting is necessary, following a set sequence of diagnostic steps. The error B18A8 relates specifically to the right blind spot information radar unit, which is responsible for detecting any vehicles in the blind spots of the Honda Odyssey. This unit plays a vital role in ensuring that the driver is aware of surrounding obstacles, significantly improving driving safety. The radar unit is situated at the right side of the vehicle, usually mounted in the rear quarter panel. Its proper functioning is crucial, primarily because it aids in lane change maneuvers by alerting drivers of potential dangers. If the radar unit detects a voltage input that is lower than expected, it triggers this DTC, indicating a malfunction that requires urgent assessment. Understanding its role highly contributes to diagnosing and resolving issues associated with this specific DTC. Several factors can cause the B18A8 error code to appear in the Honda Odyssey. One common issue could be loose or poor electrical connections, which could disrupt the power supply to the BSI radar unit, resulting in inadequate voltage detection. Another potential cause may involve faulty wiring or damaged harnesses that could lead to broken circuits or ground issues. Additionally, the radar unit itself could be malfunctioning or defective, necessitating replacement. It is essential to investigate these possibilities rigorously, as each has the potential to impair the radar's function, ultimately affecting the vehicle's safety systems. Accurate identification of the root cause is critical to ensuring a comprehensive repair. When the B18A8 trouble code is active, several symptoms may manifest in the Honda Odyssey. Most notably, the driver information dashboard will indicate the B18A8 error, highlighting the issue to the driver. The blind spot information system may become inactive, resulting in a lack of alerts during potential blind spot encounters, which could compromise driver safety. Additionally, warning lights specifically for safety systems may illuminate on the dashboard, serving as visual notifications to the driver. These symptoms not only indicate a malfunction, but also emphasize the importance of addressing the issue promptly to restore safe driving conditions. Ignoring these symptoms can heighten the risk during lane changes and other driving scenarios. The first step in troubleshooting the B18A8 code is to clear any existing DTCs using the HDS, or Honda Diagnostic System. This process helps refresh the vehicle's computer system and is important to ensure that only current faults are evaluated. It can also assist in detecting persistent problems, as the system will generate a new DTC if the issue reoccurs. To perform this step, technicians will connect the HDS to the vehicle, access the diagnostic menu, and follow the prompts to clear the codes. This foundational action is crucial because it sets the stage for further diagnostics, thereby simplifying the troubleshooting process. Always ensure that this preliminary step is conducted prior to any in-depth examination. The second step involves turning the ignition switch to the on position, specifically to on 2. and allowing a waiting period of approximately 20 seconds. This process is necessary to power the vehicle's electronic systems, allowing the modules, including the BSI radar unit, to initialize and perform self-checks. The waiting period also permits any stored diagnostic trouble codes to register correctly in the system. This step is essential for confirming the presence of the B18A8 code or checking for any intermittent issues. By ensuring the systems are fully powered, technicians can attain more reliable diagnostic data and identify whether the fault is persistent or has cleared. Following the correct ignition procedure ensures a thorough assessment of the systems involved. After the initial power-up and wait period, the next step is to check for DTCs again using the HDS diagnostic tool. This action is pivotal in establishing whether the B18A8 code remains active or if the system has self-corrected. If the DTC is still indicated, it confirms a present issue requiring further investigation. Conversely, if the DTC does not show up, it suggests possibly an intermittent fault or a temporary glitch in the system, in which case technicians will need to check for loose or poor connections. This step helps streamline troubleshooting efforts by confirming or negating the presence of the DTC. Addressing any ongoing issues directly supports the ultimate goal of vehicle safety. In this fourth troubleshooting step, the technician must turn the ignition switch to the lock 0 position, effectively shutting off power to the vehicle's electronic systems. This step is necessary to enable safe inspection and manipulation of the vehicle's electrical components, specifically the connections at the right BSI radar unit. After ensuring the vehicle is safely powered down, technicians can then examine the 6P connector associated with the radar unit. Reviewing connections with power off minimizes the risks of electrical shorts or unintended actuation of components. Safety protocols during diagnostics are fundamental for preventing damage to the vehicle and ensuring the technician's safety while performing repairs. Proceeding safely and intentionally is essential at this stage. Upon powering down the vehicle, the next step is to carefully inspect the connection at the right BSI radar unit's 6P connector. This involves checking for any signs of damage, corrosion, or loose connections that could be the cause of the low voltage reading indicated by DTC B18A8. The 6P connector is a critical interface that facilitates communication and power between the radar unit and the vehicle's electronic control systems. Inspecting the integrity of this connector can lead to immediate resolutions if any visible issues are found. A thorough examination includes looking for bent pins, moisture ingress, or broken connectors. If the connection is found to be poor, repairs need to be made to restore proper function. Properly secured and clean connections are vital to the successful operation of the radar unit. The sixth step instructs to disconnect the right BSI radar unit's 6P connector. This step is essential before measuring voltage to eliminate any possible influence from the radar unit itself on the readings. Disconnecting the connector allows for a controlled environment in which to gauge the voltage produced at the connection, ensuring accuracy in the measurement process. This step also facilitates further inspection of the connector itself for any hidden issues not visible when it's connected. It's crucial that this step is done carefully, respecting proper disconnection protocols to avoid damaging wiring or the radar unit. Once the connector is safely detached, technicians are prepared to measure voltage, which will guide subsequent diagnostic decisions. Maintaining a methodical approach ensures comprehensive examination and repair of any encountered issues. With the right BSI radar unit connector disconnected, the next step requires turning the ignition switch back to the on position, on 2. This activation powers up the necessary electronic systems to allow for accurate voltage measurement at the radar unit's connection. Utilizing a multimeter or voltage tester in this state is critical, as it will enable technicians to determine if the electrical supply to the radar unit is present and functioning as expected. Establishing the voltage during this state is vital for determining the integrity of the vehicle's electrical system feeding the radar unit. Proper execution of this step will lead to substantial insights into whether the radar unit or prior connections are responsible for the low voltage detection. A thorough comprehension of electrical diagnostics is key to understanding the results obtained from this measurement. In the 8th step, technicians must measure the voltage present between terminals number 2 and number 5 of the right BSI radar unit's 6P connector, using appropriate measurement tools. These terminals correspond to critical connections that facilitate the power supply to the radar unit. The expectation is to see battery voltage, which typically indicates that the wiring and connections upstream of the radar unit are functional and providing the necessary power. If the measurement reveals no voltage, it could point to an issue in the wiring harness or connections further upstream, leading away from the radar unit itself. This step is crucial because it also assists in isolating the problem to a specific section of the wiring or component. Thus, an accurate reading here guides the troubleshooting process to either replacing the radar unit or further investigating the electrical supply path. The final troubleshooting step focuses on measuring the voltage present between terminal number 2 of the right BSI radar unit's 6P connector and the body ground. This measurement is essential to establishing whether there is proper electrical continuity and voltage presence from the radar unit's supply path back to the vehicle's ground system. Detecting battery voltage at this junction indicates that the radar unit can receive adequate power, affirming that it is not at fault. Should there be no voltage, this situation implies a more significant issue within the vehicle's electrical system that requires further diagnostics. Working systematically through these potential points of failure is important for precisely diagnosing the problem. Ultimately, this step will clarify whether the radar unit needs replacement or if wiring repairs should be addressed instead. After completing the necessary repairs related to the B18A8 issue, it is vital to perform final repair verification. This involves confirming that all repaired components are functioning correctly and that no new issues have emerged. Technicians will once again connect the HDS to recheck for any active DTCs, ensuring that the B18A8 code does not appear again. If the DTC has cleared and does not return, it confirms the repair was successful. However, if the code reappears, additional investigation is necessary to explore deeper underlying issues, such as wiring integrity or connector health. This final check reinforces the idea that thorough diagnostics confirm the successful resolution of the problem. Ensuring all systems are operational post-repair is crucial to maintaining vehicle reliability and safety. To avoid encountering the B18A8 DTC in the future, regular preventive maintenance is highly advisable. This includes inspecting the connections to the right BSI radar unit periodically, checking for any signs of corrosion, dampness, or physical damage. Addressing these issues early can greatly reduce the likelihood of encountering problems related to voltage input low errors. It is also wise to maintain the integrity of the electrical systems throughout the vehicle, as ensuring proper servicing can preemptively identify potential faults before they escalate. Regular inspections and maintenance routines empower vehicle owners to enjoy consistent and safe driving experiences. Additionally, fostering good practices with vehicle care will promote the longevity and performance of essential safety systems, like the blind spot information radar. In conclusion, DTC B18A8 signals a critical issue with the voltage input to the right BSI radar unit in the Honda Odyssey from 2011 to 2017. Understanding this error code is vital for ensuring driver safety, as it affects blind spot detection capabilities. Following the defined troubleshooting steps allows technicians to systematically eliminate potential causes and identify any necessary repairs. The emphasis on preventive maintenance cannot be overstated, as it serves as a proactive approach to avoid similar issues in the future. Timely inspections of connections and components can enhance functionality and extend the longevity of safety systems. Ultimately, addressing DTC B18A8 with diligence ensures a safe and reliable driving experience. Please like and subscribe to the channel. See you next time.